Okay, for question 9a, fx is equal to x minus 4x to the power of half plus 1, where x is greater or equal to 0. We need to solve fx equal to 0. Writing down the equation, we can also substitute x to the power of half for y, and then x is equal to y square. Putting y square into the equation for x, we get y square minus 4y squared to the power of half plus 1. Simplifying, come down to this quadratic equation. Completing the squares, you should be able to get y is equal to 2 plus or minus root of 3. And then remember that y squared is equal to x, and therefore y is equal to root of x. So we can substitute y for root of x is equal to the solution here, and then you get all of that. Which means that after you remove the square root, you should be able to get x is equal to 2 plus or minus root of 3 to the square. I've taken x root of 3 positive here because it says that x should be equal to greater or equal to 0. So therefore, expanding using the quadratic expansion, you will get x is equal to 7 plus 4 root of 3. Now for part B of the question, we've got to solve, find the value of m and n, given that gx is equal to mx squared plus n, and then hx equal to x power half minus 2. We also have fx is equal to x minus 4x power half plus 1, and it is given that fx is equal to ghx. We can find ghx, which is the composite function. Ghx can be found as follows. Because we've got mx power half, now x is hx, so mhx power half, and substituting the hx for x power half minus 2 to the square, because we have hx is equal to x power half minus 2. So expanding this, you should be able to get this quadratic expansion, and simplifying comes down to m times all of that inside here simplified over here, plus the n there, and then expanding this, distributing whatever we have outside with inside, and you should be able to get mx minus 4mx to the power of half plus 4m. After you've come to this part here, what you do, you compare the coefficient of x. Coefficient of x is m, coefficient of x here is 1, so m is equal to 1. And then do the same for comparing the constants. Constant, I've got a constant here as 1, and a constant here as 4m plus n. So 4m plus n is equal to 1, substituting the value of m for 1, which was found here. So you got 4 times 1 plus n, so n should be equal to 1 minus 4 is equal to negative 3. So that's part B of the question. Take care.